Hi everyone, welcome to the Art of the Possible series. I'm Nihalini Yogi and I'm a Principal Cloud Solution Architect at Microsoft. And with me, I have two of my awesome peers from the app dev teams. I have Sowmyan and Eric, who are also Principal Cloud Solution Architects. And Eric is from our Canadian subsidiary. Welcome, Eric and Sowmyan. Great to have you on this session. So while working with various partners, Sowmyan, Eric, and I have often talked about how important it is for the app dev teams to collaborate with infra and security teams for any successful cloud migration. In this session, we plan to share some of our learnings. And of course, I come from an infra background and networking background, and I know enough on the dev side to be dangerous. So that's where I have Eric and Soumyan to help us on the dev side. So with that, I will show you today's topic and agenda. So today's topic is networking, a deep dive on networking inside Azure Container Apps environment. However, we will start with Soumyan, who will give us an overview of container apps and new features. And then we will turn it over to Eric. Eric comes with a very strong and a unique perspective. He comes with background in both infra and app dev side. So Eric's going to review the networking requirements. And then later we will do an overall architecture review, use cases, and scenarios. With that, I will turn it over to you, Samyan.
All right, thank you, Nahali. Let me share my screen and make sure that I have my PowerPoint open. Can you all see my screen now?
Yeah, looks good.
Okay, awesome. All right, so I will start with a quick overview of Azure Container Apps. So primarily give a quick intro about the different components that you are going to see in the later part of this particular session that we are going to cover. So if you look into the Azure as a different compute options, we have container apps is coming under the serverless compute. So we have two main compute options, which are Azure Functions and Azure Container Apps. And both are going hand in hand, means like even if you develop an application as an Azure function, you have a choice of deploying it as an Azure Container App as well. So that is a kind of seamless integration is available between container apps and Azure Functions. And from a serverless scenarios perspective, you can use container apps for multiple scenarios. Like for example, starting with an integration scenario, you can host your own APIs, and that APIs can be utilized as part of your overall distributed architecture of a microservice-based application or a workflow or anything that you're building. And if you want to expose as an API, you can host that one in container app. And then if you're working with the data analytics and the data engineering scenarios, if you want to do any kind of an automation or data processing, you can use container apps for that to run a specific job, which will be processing certain types of data along with the database or a storage account. You can do that. And then even in a heavy duty data analytics scenarios, if you want to offload certain task into a compute, then you can utilize a true serverless fashion using container apps. That is another capability. And then it's all about AI. So now if you're building an AI app or a generative AI app for any scenarios, there is a deeper connection with the Azure Container Apps, even including, like for example, if I'm using an LLM to generate some source code, and if I want to execute the source code, then Azure Container Apps is providing a true serverless code execution environment dynamically. That is another great capability, even just announced in the Ignite this year. So these are the different use cases that we are seeing from a serverless capability perspective and different use cases. And Azure Container Apps are going to be one of the de facto option that we can choose for all these kind of use cases. And Azure Kubernetes Service is our managed Kubernetes platform for the upstream Kubernetes version available. And Azure Container Apps, you can see even you can use a lot of like a jobs or high burstable workload, if you want to run that one in serverless fashion, you can go as you can deploy container apps alongside with Azure Kubernetes service, and you can use that. Same thing with the static web app or app service if you're using. These are the other PaaS compute options available in Azure. And then it's not only specific to Azure. If any other, if you look from your overall solution perspective and any other dependency, you can leverage container apps from a serverless point of view from any of your use cases. So I'm just putting all of the commonly seen scenarios over here. So again, container apps, we can think about it's more of a true event-driven serverless compute option available. You can use it for multiple different scenarios. Now let's get into a little more detail about what is container apps and its different components. So it's a serverless managed offering, and it is available as a true consumption model. Means like you will be getting some monthly credits for number of executions for free. And there is also something called a workload profile. So we have, if you want to keep this instance as a true managed service model, and if you want to run on a specific compute options with a dedicated capacity, you can provision your container apps in that fashion. And also container apps are deeply integrated with the DevOps pipeline, including Azure DevOps and GitHub. And that is another great capability. You can, with the consumption model, you can even scale to 0, and you can go to in a true hyperscale manner. That's how the underlying orchestration engine is built for a true hyperscale. And then many of the other capabilities from a container-based applications in terms of the container security, all these are built in with Azure container apps. So now let's get into the different components of Azure container apps. So it's always start with the bigger umbrella of a container apps. It's called the container app environment, and that's where we are defining the isolation and observability boundary, etc., of a particular app that you're going to deploy into a container app. And this is where your virtual network boundary also coming. So if you want to isolate your applications into, let's say, 2 different virtual networks, then you need to create 2 different Azure container app environments. And that's where we are going to deploy your container apps. So think about that is the network and security boundary perspective. The Azure container app environment is that particular the dependent component that you need to look for. Now, once you have a container app environment, and that is where you're going to create a container app. So a container app itself is going to host, like, for example, an easy way to compare is going to be if you're coming from a Kubernetes background, you can think about this is more of like a pod or a deployment. Each deployment will have its own replica. So if you create a container app, your underlying container is going to run within that container app, and you can specify the number of replicas which are going to create a number of instance. Like for example, if I need, let's say, 3 replica of that container app instance, then it is going to have 3 different instances of the same container image is going to run behind the scene. So in this case, you can see there are 2 container apps running in this container app environment. There is a container app 1 has 2 revisions and 2 replicas is running, and same thing with the container app 2. We'll get into more details of all these components. Another specific object available in container app is called the container jobs. So you can also deploy your application workload as a job. It is going to execute as definite number of tasks. So this is going to be helpful for example, the use cases that we have seen in the previous slide about the different use case, like for example, data processing and data analytics scenarios. So for this kind of scenarios, if you want to process some background jobs, you can execute them as a job in Azure Container App, and that is one of the other resource type available to deploy in Container App. And revisions, if you're again coming from a Kubernetes background, we can think about like a deployment version. So you can create that one, and it is going to be helpful when you do a blue-green deployment and canary deployments, etc. So you can create an immutable version of that particular container app, and has like a different version, and you can run that one in parallel, and you can even redirect the traffic to a specific revision. So that is another great capability available with the container apps. And replicas, as like I mentioned earlier, you can create a multiple instance of the container app, and this is going to be helpful primarily even for scaling scenarios. So you can create, let's say, one instance of the container, and you can automatically scale that one to, let's say, 10 instance. So those are controlled by the number of replicas in a particular container app. And within the replica is what real underlying container is going to run. So you can think about the actual Docker image. If you have that instance of that Docker image is going to run within that replica as a container. And dynamic sessions are the one that I mentioned earlier about. You can create a really an execution of untrusted code in a sandbox mode in a real time by using the dynamic session. One of the main use case that we are seeing in the field is primarily with AI. If I'm generating certain source code, and if I want to test the source code with a compiler, and I can do that one, like for example a Python or even a C# scenario, then I can, let's say I'm generating a C# code, I want to compile that one with the .NET, then I can easily do that one in a real world environment by using dynamic sessions in container app. And container apps also giving a concept called components. These are primarily going to be helpful. Like let's say if we are bringing certain application workload and underlying runtime needs some dependent components. Like for example, with AI, if I'm hosting an AI application, then if I need, let's say, a vector database, then container apps can deploy that vector database along with your app. It's called component. And in this case, for example, the current vector DB is an example. And with the .NET Aspire dashboard and Java, there are different services that you can integrate along with your app. So think about this like and components that you can inject into your environment, which are going to be more of a dependent service to run the corresponding workload. And then from a DevOps standpoint of view, there is a deeper integration available with the GitHub and Azure DevOps, and you can easily create and deploy with a true automated pipeline with the container apps and the container app registry. There is also another capability available called source to cloud. So instead of you manage underlying pipeline of creating a container image and push that one to a container registry and then deploy that. Instead, you can just deploy directly from your source code. So behind the scene, it will create the underlying container image and push that one to a default registry. So all these things will be done easily with this capability called source to cloud. All right, that's it. So that covers the high-level overview of container apps. You will be seeing much more deeper dive in when we do the demos and stuff later. Let me pass it to Eric.
Thanks, Sowmyan. Now let's talk about the network architecture for Azure Container Apps. And kind of like the overview. So if we look at this, we need to take into considerations of multiple things when we want to deploy Azure Container Apps. So you need to start from this slide. So you'll go from left to right. So from the biggest bucket, and then you'll refine it all the way down. So as Sowmyan mentioned previously, so environments are your network boundaries. So you need to make a decision in terms of what type of environment you're going to select. And then after that, you need to, and then it goes down to your application layer in terms of ingress controller, ingress. So that'd be Envoy proxy. If you're going to require a custom domain, are we going to do traffic splitting? We had shown you before about revisions and having, version 1 and version 2 kind of like had that blue-green deployment. And then after that, you're going to kind of keep going down the list, right? So you're going to decide like network filtering, do we need to do any IP restrictions? Do we need to modify any network security groups? Or do we need to modify kind of like the overall route of the traffic by using user-defined routes? And then after that, you need to make a decision as what is your front end. So it's going to be an app gateway or an Azure front door. So let's look at kind of like environments now. And, this is, like I said, this is like where you're going to basically decide like overall what is going to be, right? So you're going to have like two kind of like levels of it. So, excuse me. And it's going to be kind of like you're going to have your container app 1, container app 2. But again, it is the boundary of your virtual network you should primarily think about, and how you're going to do observability for your application itself. So when you deploy, if you decide to deploy an Azure Container Apps with the default virtual network, this is something that we provide as a managed service. So what that means is that this is going to be hidden away from you. You will not be able to manage the actual virtual network itself. So making some of these decisions early on is really, really important. So that way you don't have to do a redeployment of your Azure Container Apps. So some things like, your network size and and kind of like how many applications you want to deploy and such are really, really important, considerations. But, your application will receive a public IP. You're going to have a static IP for egress traffic. And you'll be able to do kind of, it also supports kind of like, IP restrictions, like we mentioned earlier, and so on. If you decide to do the custom virtual network, so this is a way to securely connect to your to your Azure resources from the internet, but also from on-premise or within your own other virtual networks that you may peer to. So this kind of gives you that ability to have that type of communication within it. So the main considerations are, based on kind of like the architecture of your application. If it's going to be, let's say, like, is it a private only application where it doesn't need to be, presented to the internet, or, or maybe you do need to have access to the internet, but then you also need to have access to other resources, within your Azure environment as well. When we compare the environments, so there are two types of environments, and I forgot to mention this, but there's the workload profile, which is kind of like the recommended environment that you would select when you deploy it. There's also consumption only environments as well. And the biggest kind of like difference you'll see is that there will be more not configuration, but more options available on the workload profile environment. So this will be like where you can actually start with a smaller subnet size if you really wanted to. So it starts at a /27, and then you can you can decide the size at that time to be as small or as big as you really need it. Versus on the consumption side, which is a /23, which is, it picks a very, very large subnet for the assumption that we don't know exactly what's going to go inside of that app environment. And that will allow you to have that flexibility to do that. If we kind of go back to kind of like optimized IP addresses, like, do we need support for, let's say, an ad gateway, so which allows for multiple more egress connections outwards, or do you need support for like UDRs? Those are kind of those decisions that are going to bring you over to the workload profile. And in most use cases that we see today, workload profile environments are the best path forward. So here's a quick screenshot of the Azure portal. And here we're kind of like showcasing the, the virtual IP, if it's going to be like internal versus kind of like external, and, like, what are kind of like the decision points here, right? So here, if we look at the default, which is external, this is kind of like where you would have this setting to publicly expose kind of like applications to the internet, right? So this is, it's available. You may still want to do some restrictions maybe, but this is primarily used for, public access. If you select internal, this is where it's only accessible through your internal virtual network inside of Azure. So that limits the capability for communication But at the same time, it doesn't mean that that communication cannot go externally. And later we'll show kind of like different scenarios with Azure Front Door and the application gateway where this fits in. Subnets, like I mentioned before, like the workload profile is a /27 as a minimum. You can grow that to a /23, /21 if you really want to. But there are certain things to keep in mind when you're selecting either one of these profiles, right? So I think one is kind of like more around kind of like how many IP addresses are reserved. So as you see, so there's 12 IP addresses are allocated for infrastructure components. So that is just to ensure that we have, as the application scales, we have enough IP addresses for the infrastructure itself. And if you look at on the consumption side, you'll notice that the container apps reserve 60 to 256 IP addresses for the infrastructure itself. Again, the consumption is when you have, it's less known and it may, where it needs to be have the scalability and agility to be able to scale to do the selections based on minimum information. So, but if you do understand your application and how you're deploying it, often and like 95% of the time, you'll select the workflow profiles environments to do that. There's also a dependency on the consumption profile, on AKS Azure CNI, the implementation. But, that's kind of like more in the background. Yeah, it's more in the background. Next slide. So when we look at ingress controllers, we have two scenarios here. So we have our internal application, which is like there's no public IP addresses. It's only available, within your Azure environment or on-prem, depending on how you have your connectivity set up. And then you have your external. It accepts, traffic from externally, but also accepts your traffic externally, basically. And then we kind of go from there. One thing to keep in mind, though, for the ingress protocols is depending on your requirement, but we only support HTTP and TCP access. So, if you have an application that requires a different type of protocol, this may not be kind of like the solution for you. And I've seen that in the past, but 99% of the time, support for HTTP and TCP traffic is, more than sufficient to cover your use case. Each application, as you see, has a default DNS name that is being provided for you, and then you can have, like a custom domain. I think we'll talk next slide on, and then we can go from there. Here we kind of show you the ability to have a custom domain for your Azure Container Apps. So this is something that is very, very simple, but it is using just you basically add the custom domain. It would go through a process of verifying that you actually own the domain by using a TXT record type. And then once it's verified, you'll be able to use that custom domain. So you'll be able to have a better DNS name than something.azurecontainerapps.io, which it makes it easier for your customers or users to come and access to. There's also just very, very quickly also as I just around there's CNI domain certificates. And we provide free and managed certificates, as part of the offering itself. And with that, I am going to pass it to Nahali. Thanks, everyone.
All right.
Thanks, Eric, and thanks, Sowmyan. Awesome overview and presentation. Let me share my screen. guys can see my screen now.
Yep.
Yes.
Awesome. So for those of you who've been following along with me on this reusable architecture journey, we will start with what I call a hybrid cloud architecture. So the top blue box being Azure, the yellow box being on-prem, connected to Azure using some sort of private connectivity. In here, it's ExpressRoute. And towards the right, you will see me navigate the layers throughout this session. And of course, today's topic is container apps networking. Okay, and these layers and these architectures are reusable. You can download it from my GitHub repo and reuse it for running your own design sessions as well. So with that, let's get started with the various scenarios that Eric and Sowmyan talked about. And we will start with the very first scenario, which is what is called an external mode. In external mode, you will notice that the container app gets deployed, and I'll make it a little bit bigger here. The container app gets deployed in its own subnet within the VNet. And if you look at the screen capture, let me show you a couple of screen captures because some of the UI bits have changed with the recent announcement. But when you deploy an external container app, like Sowmyan mentioned, there is a container app environment, which we will deploy as external. And then, of course, there is also of ingress endpoint, which is internal versus external. Now, this screen capture is from an older UI, but with the recent release of the private endpoint feature. In addition to this external mode, you will also see the option for private endpoint as shown over here. And I'll be going into the details of that. I just thought I'd show you this because it's a recent announcement. So with that, let's look at how the flows will work with what we call the external mode. And in external mode, the way the public flows would work is, again, this user, the red user, is outside, and the green users are considered inside. So this is on the privately connected branch, and this is somewhere in Azure, and the red user being external. So with the external mode, this user will hit the external load balancer, and then it in turn will hit the container app, right? So behind the scene, it does provision an external load balancer. Now, if this is not something that is desired in your environment, again, this is the new preview feature. You can drop a private endpoint, and then the flows would look something like this. The external user will no longer be able to access this uh, external load balancer, and then they would be hitting it through the private endpoint. Now, what if you do need access to this from publicly? That's where the front door comes in, and you could put this as an origin to the front door or a backend, and then the flow this user would hit the front door, and which will in turn hit the private endpoint. Like Eric mentioned, we do support custom domains with front door, and I will be showing you a deep dive video on or a demo in the portal in part 2 of this series. But with that, I'll pause here for a second. Eric, Sowmyan, would you like to add anything to the external mode use case?
No, all good, Nahali. You covered pretty much the scenarios. Yeah, like we are seeing that one more of a test and experimentation POC stages. So that is what we are seeing in the field.
Right. And like with the private endpoint, I think it will change it a little bit where once it goes into GA, it will get used behind the front door. But yes, like the native public flows, this is like Soumya mentioned, mostly for POC. So with that, I'm ready to dive into the second scenario, which is the internal mode. Now, with the internal mode, you will deploy, when you deploy the container app, it also deploys behind the scene an internal load balancer. Okay, and like these are, like Sowmyan mentioned before, they're like more like pods and replicas behind the scene. So these are two container apps, and consider the green box as the container app environment. And within that, I have an app and I have a Redis container app. So I have two container apps, and notice the flows, right? So what we're showing here is that there are two types of settings, and I'll show you the screen capture to kind of go over what that means. And it's a little bit fuzzy, but it's important enough to show. So if you notice this app is limited to the VNet. In other words, it can talk to anything within the VNet. Anything within the VNet can talk to it. However, this Redis one is limited. As you can see at the top, it says limited to the container app environment. And what that means is that when the user tries to access it, the user can hit this internal LB, but it cannot hit this directly. Okay, so that's the idea, to kind of have a very secure deployment, is to limit this Redis, for example, to the container app environment only. So with that, let me talk a little bit about container app and private endpoints. So for this user to be able to successfully access this container app environment, we do have to provision a private DNS zone, and this is how you would set it up. And you would create this manually, remember. And if you click here, you will see that this IP is the static, this IP is the IP of the load balancer that sits in front of the container app environment. Okay, so that's how you would set up a private DNS zone, and be sure to link it with your VNet in question. So that's what this VNet link is showing. And once you have all of that in place, this user will be able to access the container app using the full FQDN. We've often seen, customers kind of get ask for this question about this. So we're showing this as a deep dive here. And then let me hide some of this and show you one more classic integration lately we're seeing. So let's say that you did have an Azure AI service, and you want to privately access it from this app. So the way you would do it is you would project this private AI service as a private endpoint, and then this app can safely, securely access this private endpoint. As you can see, this design is very enterprise ready. Everything's accessed securely. However, if you see here, um, we can access it internally only. In other words, this user can access it and this on-prem user can access it. How can we access this from the public internet? So there are two potential designs, and I'll go over both. So one way to do this is, because this is internal LB, this user cannot access it from the internet, right? So what we do is we will use a application gateway over here. So, and your container app would be the backend to the application gateway, and then the user can hit it from outside using the public IP of the application gateway. Again, custom domain is supported here as well. And with that, I will stop about this use case over here and see if Eric, Sowmyan, if you have anything to add to this use case.
Yeah, I think the last use case is specifically with the app gateway. That is one of the common use case that we are seeing, because app gateway is giving that the layer 7 and firewall protection. So especially on a regional workloads. So that's a great use case.
Yeah,
Excellent.
completely agree. So, man, like this is a very typical use case, great way to, provide external access securely. But the only thing that kind of comes to mind is, based on this scenario is, you know, DNS plays a critical role here from internal access as well as external. So having that linkage and configuration done is so important to making this work.
Yeah, couldn't agree more. Couldn't agree more. I do have an optional layer over here, and this is if you did have to set it up for on-prem, right? This is even more trickier, and I've done a deep dive video on just the DNS configuration, but you do need to set it up end to end for this to work right. 100%. Yeah, so thanks, Sowmyan, Eric. Great stuff, great comments. The other thing that you could add to this is we could bring front door to the mix. And with front door, instead of hitting the app gateway directly, you could have this app gateway as the origin to this front door, right? So you could add that as a backend, and then the flow would look. So let me remove the app gateway from the mix and from the direct flow versus this is going through the front door. Now, I will say that with front door configuration, um, there was today you have to do this manually through the PowerShell or like AZ-CLI. The direct integration with private endpoint is not supported through the portal. So with that, let me show you one more scenario here. So one way, like I mentioned, two ways to make this publicly available. One is with directly to the app gateway, and the other one is with front door. Okay. And I'll just call out a minor detail here, but it's important to understand the why we cannot do this is if you look at this internal load balancer, you could not put this exactly right behind the internal load balancer using PLS, because the way the internal load balancer is set up is it uses IP-based backend pools. Okay, and that's the reason that you cannot put this load balancer directly behind the front door. So that's why you would use either an app gateway like I showed you earlier, or you would use a front door. Okay, so that's the technical reason. I think the new preview feature that I showed you with private endpoint opens up a lot of the design options, but that was what it was. As of a couple weeks ago, this design was quite popular. Anything else, Sowmyan, Eric?
No, that's a great use case, like especially if you are building an application with a multi-region deployment with a larger distributed application use case scenarios, then front door, putting in that one as a front line is always going to be a good way of implementing it for the load balancing as well as availability perspective. So with that, this is great.
This scenario, right, Sowmyan, where
Yep,
you would
exactly. Yep.
have, okay, yeah, good call out. Yeah, so this is a multi region scenario, and we'll do something similar when the private endpoint goes GA as well. But this is the current multi-region architecture that we've recently done for a couple of our partners as well. So one more use case that I would like to add before we break is So far, the flows that we have looked at, again, they're all color coded. So these green flows are all inbound flows, right? Inbound from the perspective of this user, inbound from the perspective of this user in Azure or from a remote branch. And the pink flows are the app communications, the load balancer talking to app talking to another container app, right? Those are the pink flows. Of course, the red flow is the one that's not allowed. And then the orange one showing the back end. So this is the origin for the front door, and this is the back end to the application gateway. Now let's look at the outbound flows. So let me hide some of these layers so we could look at the outbound flows. Again, the outbound is from the perspective of the container app. So there are two options when it comes to outbound. Eric covered this in his session as well. But if you're using the NAT gateway, let me zoom in a little bit more. You can set it up so that you can associate this subnet, the container app internal subnet, with the NAT gateway, and then you can, once you console into the app, and this is what I have done over here, and we'll do a demo as well, but just so you have a view of how it works. If you run curl ifconfig.me, it goes out to the internet using the public IP of the NAT gateway. In other words, in this picture, this IP for the curl command and this IP for the NAT gateway matches, and this is the NAT gateway in question. Of course, has to be associated with this subnet. Okay, and with that, the second option for outbound is using the UDRs. And UDRs is where you could have an Azure firewall for egress, or you could have a network virtual appliance, and you would be pointing your quad 0 route via the Azure firewall in this case, or an NVA. So you can egress using the Azure firewall, or you can egress using the NAT gateway. So the blue flows are showing the outbound connections. So with that, I think as part 2 of this, we'll show you the portal experience, and we'll run different validations and troubleshooting. And with that, any last thoughts before we end the session today?
Yeah, that looks pretty good, Nehali. You covered pretty much all different scenarios.
Yeah, I would
Awesome.
say like this is fantastic, Nali. And I would just add that, Azure Container Apps is a great way to remove kind of like that operational overhead when your developers are developing the application, and it requires less less day 2 support, I guess we'll say, from an operations or IT perspective. So these scenarios are fantastic, but just want to add that quick point in for Azure Container Apps.
Awesome. Thanks, Eric, and thanks, Sowmyan. And thanks everyone again for joining us. We'll do part 2 of this recording, where we'll showcase the demos, validations, and run through some troubleshooting exercise. So be sure to join us in the next video.